So, Namaskar all. We are seeing the phase rule in that in the earlier podcast I have explained the terms used in the phase rule, and today we will see the phase diagram of water. So the topic for today's discussion is phase diagram of water. All of us know that water exists in three different forms, that is water as liquid form, vapors, that is in fact steam as vapor form, and solid form is ice. So in your general observation you might have seen the water which is boiling. So water in equilibrium with its vapor. So when water boils, H2O in liquid form is in equilibrium with H2O in gaseous form. When water is kept in refrigerator, so when water freezes, what you see that H2O liquid is in equilibrium with H2O solid, and you might have also seen the vapors arising out of ice in summer season. If you keep it in open, you will see vapor of ice, vapor of water around ice. So these are some of the equilibriums that you have observed, all of us observe. But is it possible to imagine that all the three forms of water coexist, that we can see in a single box or single system where all the three forms coexist? Is it possible? And majority of you won't imagine that yes, it is possible. But if we go by phase rule, then we can ascertain certain things, or we can predict certain things. For example, the phase rule suggests that F is equal to C minus P plus 2. This is the phase rule. And if we consider water, if applied for water, then what happens? Component is 1. Only one component is there, then F is equal to C minus P plus 2 becomes 1 minus P plus 2, and that becomes 3 minus P. Thus, for this equation, for this particular equation, if only one phase is present, if only liquid is present, then F becomes equal to 2. 3 minus 1, that will be 2. If two phases coexist, then F becomes 1. 3 minus 2, 1. And if we imagine, or if we consider that all three phases coexist, then P is equal to 3. 3 minus 3 will be 0. And yes, it is possible that degree of freedom can be 0. The only condition is that degree of freedom cannot be negative. So with this knowledge, we will proceed further. This knowledge also tells us about the fact that any component, any one component system has maximum degree of freedom 2. Thus, such a system can be represented by a two-dimensional diagram, and if two-dimensional diagram can be drawn, then the most convenient variables are pressure and temperature, assuming that the volume of given water is fixed. We have not added the water, not taken out any water. Once we assume some water, say 1 liter, then for such a system, if P can be 1, the degree of freedom can be 2. So maximum degree of freedom can be 2, and we will see a two-dimensional diagram of phase diagram. Here you will see uh, the phase diagram of water. One of the axis is pressure axis, the other axis is temperature axis. So x axis is temperature, it is increasing towards right, and pressure is increasing towards up. You can see that the diagram has such type of curves, and in that three regions are there. We will see the diagram and we will see how to read the diagram. Say if the temperature is increasing, when the temperature increases, then water boils, water is converted to vapor. When temperature increases, therefore when we go from this side to this side, this should be the vapor form. And yes, it is, water is in vapor form in all the uh, area that is given, A, B, C, you can see. And as you increase the pressure, the molecules come close and thus they get converted into solid. When pressure is increased, anything gets compressed and it turns from gas to liquid to solid. So at extreme pressure, as pressure is increasing, we can see that the water is converted to solid, that means ice form. There are three lines which are meeting at a point, point B, and the three lines have created three zones. We will see the zones, those are areas. So if we consider area A, B and D, or we can go with the area of your knowledge, that is area A, B and C. So this zone we are talking about, and in this zone, that is area A, B and C, this area, obviously this is the point, this is the area. Water is in vapor form. In area A, B, C, water is in vapor form only, and thus only one phase exists, and that phase is P is equal to 1, that is gaseous phase. And the phase rule can be written as when P is equal to 1, F is equal to C minus P plus 2. Component is 1 and phase is 1. In such case, F is equal to 1 minus 1 plus 2. Thus, F is equal to 2. Degree of freedom is 2 in area A, B, C, and when degree of freedom is 2, what does it mean? It means that you can define this area by means of two parameters, and those are temperature and pressure. Two degree of freedom are there. Temperature and pressure is required to define this area. What does it mean? You can see that there are many points on the say this particular graph. There are many points in the area A, B and C. All of them, what they represent is that if we consider say this area, oh, it is getting deleted, something happened. So we'll create one more slide, so that should not cause a problem. Yes. So if we consider the area that is A, B and C, then one point, if this is the point, consider, if this is the point, consider, if this is the point, consider, this and all these points. You can see that in all these points the system has only one phase, but every point has some temperature and some pressure. So you need to explain temperature, or you need to define temperature as well as pressure to keep water in one of the phase, that is vapor phase. And this is the meaning that temperature and pressure is required to define the system in that area. If we consider another area, that is CBD, area CBD is for water as liquid. So all this area, water is in liquid form, and thus again component is 1, phase is 1, that is liquid. F is equal to C minus P plus 2, and that becomes 1 minus 1 plus 2 is equal to 2. Again you require temperature and pressure to define the point. We can similarly consider the area that is A, B and D. area A, B and D. Area A, B and D has water in ice form. Again, P is equal to 1, C is equal to 1 and therefore F is equal to 2. So you will have to define temperature as well as pressure to define area ABD. Thus, in any area degree of freedom is 2. Now we will look into the curves on this particular system. That is, we will start with curve BD. Curve BC we will take. Curve BC has vapor on one side, this is the vapor side, and liquid on other side. So on the curve, water will be in equilibrium with vapor. Thus, H2O liquid is in equilibrium with H2O gas. And on the curve, both the physical forms coexist. So H2O liquid will be in equilibrium with H2O gas. That means two phases coexist on the curve, and thus P is equal to 2 and C is equal to 1. And in such case, F is equal to C minus P plus 2, that becomes equal to 1 minus 2 plus 2 is equal to 1. And degree of freedom is 1 on curve. If you observe that on the curve, you can change only one thing. You cannot change both the things. If you change both the things, then the system will lie in one of the zone. Either it will be in the gaseous zone or in the liquid zone. Thus, on each point, you can see this is the point where we are satisfying the condition. Here, if you define pressure, temperature will be automatically defined. You need not define, because you have to abide by the condition that two phases will coexist. Say, take next point, this point, you have the condition that two phases should coexist. Then if you define temperature this, then pressure you have to set automatically this one, so as to bring two phases in one equilibrium. Thus, on the curve, degree of freedom is 1. We can take another example where curve DB is taken. Also, for this curve CB, as water is in equilibrium with vapor, it is the vaporization curve of water. Because water is converted to vapors. You can also see reverse, it is condensation curve of vapors. In curve DB, ice is in equilibrium with liquid, and thus we can write H2O solid is in equilibrium with H2O liquid. In such case, again two phases coexist and component is 1, thus F is equal to C minus P plus 2, F is equal to 1 minus 2 plus 2, that gives 1. So again only 1 degree of freedom is there on the curve. And you can see that this solid is in equilibrium with liquid, that means it is melting point curve of ice. We will move to the discussion of next curve, that is the curve of ice in equilibrium with water vapor, that is curve AB. On curve AB, it is separating ice and water vapors, but on the curve ice will be in equilibrium with vapors, that is solid form is in equilibrium with liquid, and when solid directly converts into liquid, it is called as sublimation curve. So this curve is sublimation curve of water, where on the curve two phases coexist and thus F becomes 1. So on the curve only 1 degree of freedom is there. So we can see that in all areas, for all areas, F is equal to 2. For all curves, F is equal to 1. So you need not see the type of curve, or you need not see the phase, which phase it is. So uniform and so unique is the phase rule, that only the numbers can define or predict what will be the degree of freedom. Now, one interesting thing in the curve is the point, that is point B on curve. Point B on curve is such a point where all the three areas meet, all the three curves meet, and thus on point B, water in liquid form is in equilibrium with water in solid form, which is in equilibrium with water in gaseous form. So all the three forms coexist on this point, and therefore our three curves, that is DB, CB and AB, meets on this point, and solid, liquid and vapors are simultaneously at equilibrium, and therefore this point is called as triple point of water. Point B in the diagram is called as triple point of water, and that triple point is at 0.0098 degree centigrade and 4.58 mm of pressure. You can see that this point is way below 1 degree centigrade and the pressure is below atmospheric pressure. At that particular combination, water exists in all three phases. Interestingly, on this point, if we draw the if you put all three phases coexisting and component is 1, then the phase diagram becomes C, that is 1 minus 3 plus 2, and therefore F becomes 0. What does it mean? That we do not have any degree of freedom. If we try to change the temperature or pressure from these factors, then we will land into one of the curve or one of the area. That depends how much deviation we uh, did, and therefore we do not have to we do not have any liberty to adjust temperature or pressure. And because we have to maintain all three phases, if we are talking about all three phases coexisting at a point, then we do not have anything to vary, and therefore the degree of freedom is 0. You have to maintain one temperature and one pressure so as to obtain the water with having equilibrium of all the three phases. So this is about the general characteristic features of phase diagram of water. There is one metastable curve in the phase diagram, and that curve shows something. It should be here. That curve shows that though water lies in the area of solid, it should have been solid at that physical parameter, pressure and temperature, but still it remains in liquid, and that is called as the metastable state of water. It is the supercooled state or supersaturated solution which is having a stable liquid state in given condition, and if any disturbance causes, then it suddenly turns into the ice. Usually such things happens because to have something in crystalline ice form, you need to have some scratch or some point of growth, and that if you do not get, then the metastable state of water occurs, and that suddenly changes into ice completely if you disturb it. So this is not the scope of this is not in the scope of discussion here, but I will wish you to go through the curves, points, curves, points and area of the phase diagram of water. Those are the important things to study in this phase diagram. So I will stop here and see you in with some other topic. Thank you.